Okay. So, here, I'll put this here for whoever's online. Starting here, you should have put y plus 23 equal to 63 because you have vertical angles, and then simply solve for y. I'm sure most of you got this one, no problem. Y equals 40, and that's your answer. You're solving for y, not the angle measure. Yes, these angles are equal. This is 63 degrees, but it's asking for the value of each variable. Then to find this one, you may have noticed that you have a linear pair, so therefore these two angles are supplementary. So that means this plus this would equal 180. So 2x minus 17 plus 63 equals 180. If you did it a little bit differently, that's okay. As long as you got x equals 67, you did it right, whichever way you did it. Then from here, combine negative 17 plus 63, so it'd be 2x plus 46 equals 180. Subtract 46 from both sides, 2x equals 134, and x equals 67. We're done. Some of you might have done 180 minus 63 to get this angle, which would be 117, and then you could put that equal to this, and you could solve it that way too. That would work. Oh, I didn't realize how tiny that was, sorry.
Well,
Good?
I don't think that would work if you did it the vertical way.
Well, these two angles are, I know I second guessed myself too. You're thinking it's going to be 50?
Yeah.
Is that what you're thinking? Yeah, I totally stumbled on that too today. But it's subtracting 17, so you'd add 17 to the other side, so it wouldn't be 50 each.
Oh.
Yeah, I was like, did I do something wrong? Yeah, I saw it that way too. Okay, number 2. These have to do with these concepts over here, but while we're over here, we're just going to solve. And the concepts, honestly, we've learned before. We're just learning the concepts in a different format today. So, given angle 2 and angle 3 are complementary, so that means 2 and 3 right here, these angles would equal 90 degrees together. And then angle 1 and 4 are congruent. They're the same measure. And then they tell us that angle 2 is 28 degrees. And then we're going to find the other angle measures. The one thing they didn't tell us, but they showed us that we're expected to recognize, is that these 4 angles form a straight line. So therefore, these 4 angles add to 180. Okay, so first off, I'm going to find a measure of angle 3, because I can do 90 minus 28. And that comes out to 62. So angle 3 is 62 degrees. Then next, to find 1 and 4, all 4 angles add to 180. We know that these two add to 90, so we can do 180 minus 90 to get 90. Correct. So since they are the same measure, you do 90 divided by 2, and you get 45 degrees. Why is it making that noise? It better not die on me. Okay. 45 degrees each. It's like a puzzle. No? Maybe. Okay. Next, for number 3, it says 2 and 4 and 5 are supplementary. Let me get a highlighter of some sort. Where is my highlighter? No, where is it? Anyways, okay, 2 and 4 right here are supplementary. And then 4 and 5 are supplementary, which we can see that one actually. 4 and 5, we can see they make a linear pair and they're going to be supplementary. It tells us that measure angle 4 is 105 degrees. Okay, so from here, this linear pair right here, we can do 180 minus 105 equals 75. So this must be 75 degrees. And then we're also told that this is supplementary to this, so this must be 75 degrees. And then for number 3, we can see that those two are going to be supplementary, so it's 105 degrees. I found it. Okay. So now we're going to go to the first part of the lesson. That's all like the math stuff we're doing today. The rest is proofs, which might be a good thing for some people, might be a bad thing for others. I don't know. Did you find the proofs hard yesterday or easy?
Hard.
Hard or easy? Okay.
In the middle.
In the middle?
I got an 8.5.
Some were easy to do and some were like.
Yeah. As I'm going through the proofs, like as I'm showing you how to do them, I'm going through it very quickly because know if I use too much wait time, I'll lose your attention. But honestly, if I was to do this by myself without an answer key, I'd sit there and stare at it for like a couple minutes to try to figure it all out. So take the time to sit there and stare at it, figure it out, because the same situations repeat themselves, and it doesn't get easier. So just take your time with them. So that way you've seen the situations before. When they come up, you'll know what they're looking for. Okay, first postulate of the day is protractor postulate. All that means is that you can take an angle and measure it with a protractor. You would line up the vertex with the center, line up the bottom ray, and then you can use a protractor to measure the angle. Second postulate of the day, angle addition postulate, is similar to segment addition postulate. Remember with segment addition postulate, we could say that this part of the segment plus this part of the segment equals the entire segment. The same thing with the angle addition postulate. We can say that this part of the angle plus this part of the angle equals the entire angle measure. The way we would write this is measure of angle ABD plus DBC, measure of angle DBC, equals measure of angle ABC, the entire thing. Remember, when you're naming angles, you need to name the points in order, and the middle letter is always the vertex. Angle addition postulate. Okay, now on to the theorems. These ideas, most of them you've seen before, it's just giving it a theorem. The first idea is vertical angle theorem. If two angles are vertical, then they are congruent. This theorem specifically needs like the most popular award. This one in transitive are like BFFs that are so freaking popular, they're in every problem. Vertical angle theorem. And the idea is, as you may know, if you have two intersecting lines, 1 and 2, opposite angles are equal. So here, measure of angle 1 equals measure of angle 2. Vertical angles are congruent. Complement theorem. You know complementary angles add to 90 degrees. Complement theorem is if you have two angles that form a right angle, two angles that come together to form a right angle, then they are complementary. Here, angle 1 plus angle 2 equals 90 degrees. Next, supplement theorem. Two angles form a linear pair. They are supplementary. So here we have a straight line, a linear pair, 1 and 2. They're supplementary. Angle 1 plus angle 2 equals 180 degrees. Thank you. Next. Okay, here's a new idea. If two angles are complementary to the same angle, then they are equal or congruent. So if angle 4 and angle 5 are complementary, and I'm abbreviating here, angle 4 and 5 are complementary, and angle 5 and angle 6 are complementary, then angle 4 is equal to angle 6, or the measure of angle 4 is equal to angle 6. Why does that happen? Well, let's look at it. If angle 5 was 60 degrees and we're told that 4 and 5 are complementary, that means angle 4 would be 30 degrees. If we were told that 5 and 6 are complementary, it means angle 6 would be 30 degrees. So if 4 and 6 are both complementary to 5, then 4 must equal 6. Congruent supplement theorem, same idea except with supplementary angles. Angle 1 plus angle 2 equals 180 if we're told that they're supplementary. And then angle 2 plus angle 3 equals 180. Then angle 1 must equal angle 3. So if this was 150 degrees, 1 would have to be 30 degrees, and 3 would also have to be 30 degrees. Okay, thank you. Next. Good. You got it all? You gonna yell at me if I move it? Okay, good. This is review over here, right angle theorems, just giving it formal definitions. Right angle theorem, perpendicular lines intersect to form 4 right angles. So over here we're going to draw a picture. Here is our perpendicular lines. We got a 90-degree angle right here. Perpendicular lines intersect to form 4 right angles, so therefore this would be 90 degrees, 90 degrees, 90 degrees, and 90 degrees. Also, all right angles are congruent, which makes sense if they're all 90 degrees. Perpendicular lines form 4 congruent adjacent angles, as we can see. Congruent as in they're the same measure, adjacent as in they are right next to each other and they share a side. And down here, if 2 angles are congruent and supplementary, then each is a right angle. If 2 angles are congruent and supplementary, then they'd both have to be 90 degrees. The next theorem, notice I'm not saying the theorems by their numbers because the numbers aren't important. That really has to do with the book that it's from. If 2 congruent angles form a linear pair, then each is a right angle. So a linear pair is 2 angles that form a straight line. If 2 congruent angles form a linear pair, then they both have to be 90 degrees. Because 180 divided by 2 would be 90. Okay, there's this little sentence down here, but it's important. The reflexive, symmetric, and transitive properties also apply to congruent angles. So reflexive property for angles would look like this. Angle A equals angle A. Symmetric would be angle A equals angle B, therefore angle B equals angle A. And transitive, if angle A equals angle B, and angle B equals angle C, then A equals angle C. Okay, lots of information. Now we're going to apply it down here. Dun, da, da, da. Okay. So here's different situations. All we're going to do is choose a postulate or a theorem to substantiate the situation. So kind of like proofs, but not an entire proof. And to be honest, on testing, sometimes they'll have an entire proof like this. Other times they'll just show you a situation and you have to identify the proof that's going on there. So here it says given, we have intersecting lines, 1 and 2. Conclusion, 1 is congruent to 2. That is vertical angle theorem. How much do you want me to abbreviate? Angle theorem. Next, situation number 5. 1 and 2 are complementary, so these would add to 90. And then 2 and 3 are complementary. And it's saying 1 and 3 are congruent. That would be that congruent complement theorem. Remember, you're never like coming up with these out of thin air. It's always an answer bank or multiple choice or something. Then number 6, 1 and 2 are right angles, so therefore 1 is congruent to 2. Looking at our right angle theorem, there is a theorem that says all right angles are congruent, so all right angles are congruent. How do you like that for abbreviating?
Can we just put the number in the
No, because the number doesn't mean anything. Like if you know it by the number, it doesn't matter. Number 7, 1 and 2 are supplementary. You can see that. 2 and 3 are supplementary. We can see that. So therefore 1 and 3 are congruent. That is congruent supplement theorem. And the last one on the page, 1 is congruent to 2. 1 and 2 are supplementary, so therefore 1 and 2 are right angles. That is Because if two angles are congruent and supplementary, then each is a right angle. If two angles are congruent and supplementary, holy abbreviation, then two right angles. Kind of looks like Egyptian. If two right angles are congruent and supplementary, then you have two right angles. Okay, next. And we get to the proofs. We only have a few today. Okay.
You have it done?
What, she did the proofs all by herself?
No,
Oh.
no, I just did the page and it's time.
Oh, gosh.
I'm in the back then. Next.
If you have trouble with the formatting, try downloading it first, like off Schoology and then print. Okay, next. Guys, quiet so I can teach. Thanks. Okay, before we even look at what's going on here, make sure that you have your given filled in, because that's easy points. And then also make sure that you have your proof, your last statement filled in, because again, that's easy points. Okay, now we're going to look at the given in comparison to the picture. It says 1 and 3 are congruent, and then prove that 4 and 6 are congruent. Okay. Second statement in our proof, it says 3 and 6 are congruent. I look at the picture, 3 and 6 are vertical angles. So, vertical angle theorem. Then our next reason is transitive. Looking at what we have here, if 1 and 6 are both equal to 3, then angle 1 must be congruent to angle 6. I don't know why I crossed that out, but it does make it easier for me to see. Maybe it makes it easier for you too. Okay, and then next it says 1 is equal to 4. I look at the picture and they're vertical angles, so vertical angle theorem. And then it says 4 is congruent to 6. Well, when I look at the picture, I can't make that connection, but over here, if 1 equals 6 and 1 equals 4, then 4 and 6 must be equal, so that's transitive. And we're done with that. Over here, I mentioned that there's actually different formats for proofs. There's 2-column proofs. I've just been sticking with that because proofs are hard enough as is, and putting in different formats is just going to make it confusing. But the other 2 formats is a paragraph proof, which we're going to look at. And the other format is like a flow proof, where you have a given, and then you have like your reason, and your statement, and your reason, and it looks like a flow chart. But essentially, it is the same thing.
Are we ever gonna do this?
We will, and I'll slowly start incorporating them. It's the same thing though. So here we have a paragraph proof, which is just a 2-column proof in a paragraph format. So we're gonna go ahead and fill stuff in. It is given that our given is angle 1 is congruent to angle 3. We know that, and the next thing says angle 3 is congruent to angle 6 since vertical angles are congruent. So by the transitive property of congruence, we can say that angle 1 is congruent to angle 6, and I'm just pulling it from the chart over here. And then angle 1 is congruent to angle 4 by the vertical angle theorem. Therefore, we can conclude that angle 4 is congruent to angle 6 by the transitive property. Okay, next. Okay, first of all, before I look at anything, I'm plugging in given, because that's easy points. And then I'm looking at what the given is in relation to the picture. So it says Km bisects JKL. Remember, bisects means cuts in half, exactly in half. So with that cutting it in half, then both these angles are the same measure. Okay, first statement here, it says JKM, I'm looking at what they're talking about, JKM is equal to MKL. They're saying that these two angles are congruent. The reason why they can say that is because the definition of angle bisector. And here we have JKM plus MKL equals JKL, the whole thing. That is angle addition postulate. And then MKL plus MKL equals JKL. They're using substitution here. Substitution can be the hardest one to determine. You could sit here and figure out what they substituted. They substituted MKL for JKM because it was equal to JKM. But figuring out what they substituted is sometimes challenging and can give your brain, like, I don't know, it can make your brain hurt and work very hard. Honestly, as a teacher sitting up here, sometimes it's even hard to figure out what they're substituting. Here's my hack. When you're up in front of an audience, in front of 30 kids, and you can't figure out what they're substituting, all you do is you look at what they're saying, okay? If MKL is plus MKL, that's not even in the picture at all, MKL plus MKL. So therefore, in order for them to get this, they'd have to substitute something. So it's substitution. Then next, to go from this to this, they combine their like terms, so they got 2 MKL. And so you could call that simplifying. Sometimes they call it substitution. And then the last step, they divide both sides by 2, and that would be division property. Okay, last but not least, the last proof of the day. 1 and 4 are a linear pair. Actually, before you look at this, remember, fill in your given. Fill in your proof statement. And then this is one of those specific ones where it has 2 spaces for a given. They put the first part of the given here, and then there's another space for given, so that would be the second part. Angle 1 and 2 are supplementary. Okay, even if you didn't understand a thing, you just got half of it right. Okay, so 1 and 4 form a linear pair. We can see that. They're also saying that 1 and 2 are supplementary. Okay. 1 and 4 form a linear pair. That means 1 and 4 are supplementary. So angle 1 and angle 4 are supplementary.
Could I just put like angle 1 plus angle 4 equals 180?
That's what I put at first, and it would work, but it would make this part harder. So 1 and 4 are supplementary, 1 and 2 are supplementary. That means 2 and 4 are equal. Oh wait, I should put an equal sign. I'm writing what I'm thinking. Okay, angle 2 and angle 4 are equal because of the congruent complements theorem. Next, angle 2 is equal to angle 3. We got to figure out where they got that from. Look at the chart. Angle 2 and 3 are vertical angles, so that's why they said that. Vertical angle theorem. And then last but not least, transitive. If 2 is equal to 4 and 2 is equal to 3, then 3 and 4 are equal, and that's what they put. And we're good. We bueno. Okay. Last 20 minutes of class. Should I get laptops or phones? Are you actually going to do your homework? Just so you know, with your phones, if you use the Schoology app, sorry, what am I thinking? The assignment is not compatible with the Schoology app. It won't show up right. The formatting will be all messed up. But if you use Safari, the formatting will work and you can use your phone. If you'd prefer to use a computer, which is way easier, use a computer or a phone. Get your work done.